Hello, we are live. This is the first time we've done a live stream, but it is Friday afternoon here at Goliath. We thought we'd try it out. I'm here with Dan and John. Hey, guys.
Hello.
Hey. It's been only a few hours since I saw you in the flesh.
Oh, yes. Dan and I live in the same city, so that is a very nice perk for an all-remote company to have one of the people actually be local.
It's a very nice perk for Chris, let's say. So. Actually, no, I'm definitely winning this relationship in terms of hardware exchanged. So
Theft.
Yeah.
I think hardware theft is the.
No, not theft. It is given willingly.
I'm like a disposal facility actually for Chris's hardware. Is more
that is correct. Yeah, I have gotten more e-waste. He's like basically an e-waste processing plant. I feel sorry for Dan's partner, though, who also has to deal with all the e-waste that is sent his way.
Except it's not waste. So. It's actually being upcycled, if I understand correctly.
Ooh, David Moon, I just saw was in the chat. David and I went to college together.
All right. Yeah, Stan is the one who shared this on his social, so it's nice to have someone here. This is literally like turn it on and see how this goes. So we might try it again. Who knows? How all good things start, where there's no promises later.
Right.
We thought we would share some of the stuff we've been thinking about, what we've been working on. John has been working on some GitHub Action stuff. Maybe you want to show that. I have some stuff I need to do to update the Astentis, which is our PCB front panel for our reference designs, so I can do some KiCad stuff. Dan has a whole bag of tricks, I'm sure, that he could show, one of many, many things. There's no agenda, though, so what should we start with? John, you want to start? Or should I pull up KiCad?
I guess. Yeah, let's start. Let me prepare some things. If you give me a moment. So maybe I should start from the beginning.
Let's start from the middle.
Middle up.
Exactly. Okay. Share screen. Share the correct screen. So one of my professional pastimes is developer tools. I think is a fair thing to say. And Goliath has lots of great engineers. I pretend to be an engineer sometimes. And I've added to my resume junior GitHub Actions engineer, because GitHub Actions is actually a really cool piece of technology. It's generally free and for GitHub users, and it's really good for automation. But it's actually not. Well, most people use GitHub Actions don't write firmware or design hardware, and the knowledge space of using GitHub Actions for tools and just the workflow for hardware and IoT engineering is just, you can't Google it. It kind of all started for me picking this up because the Zephyr community, Zephyr RTOS is one of the RTOSs that we love and we contribute to. People were asking for embedded containers, so using something like Docker to package up your tool chain so it's reproducible. You can run it on your machine, you can run it in the cloud.
And just so you know, Docker is it's a virtualization platform.
Well, I used all of my willpower not to jump in and say what Jonathan means here is OCI images, of which Docker is one mechanism to build and manage.
We got to be more casual about this, right? If this is going to be a live stream, we can just.
But Dad can nerd say me.
Jonathan said we have some very good engineers at Goliath. We also have some very pedantic engineers at Goliath. One of which is here right now. So.
Maybe in a future live stream, I'll go through all the corners of the internet and weird things I've tried related to developer tools and hardware. And yes, many of them involve me pinging Dan late at night, asking like, how does this thing work? Can you explain it to me? Yeah, speaking like a 5-year-old. We just heard on a previous call that a 7-year-old is able to put together some hardware. So I feel like we're gonna go for this. Speak like a 7-year-old. So the mini project I had was trying to make these OCI compatible containers for Zephyr, and I never tried GitHub Actions before, and so I learned it to build these containers. And if I switch over to the right tab, basically these are different containers with all the basic toolchain for specific hardware architectures that support Zephyr. It bundles the compiler, some of the dependencies for Zephyr itself, and it's actually pretty neat and small. GitHub doesn't show the size I was able to do, but instead of a 11 gigabyte container, which is what is provided by the Zephyr project, these are an average one plus or minus 1 gigabyte. So as an engineer or the system you're running on, it's really nice because it's optimized and faster and smaller, all the good things, right? Well, there are 25 different tool chains that are part of Zephyr because Zephyr is this huge cross-platform multi-target RTOS. So manually building this would have been infeasible for me, especially since this was a side project. And so I ended up diving into Docker containers. GitHub Actions to build Docker containers. And
to build
I don't know how
OCI images is what Jonathan meant to say. That's the other. I promise I will stop being annoying.
Dan is adding context here. It's
the other. If you talk to anyone who like does a lot of OCI image things, the other pedantic thing is containers versus images, right? Because when you run it, right, it's a for a container. But it itself is just an image. So anyway,
yes,
again,
yes,
I'll stop.
and I think it's good because I'm always trying to reframe it like the firmware engineers, like someone told me to use Docker and I need to run a container. Can someone show me how to do Docker containers? Which is not to be pedantic about it, but like missing a lot of the details. But under there's actually, you have to understand all those things. You have to understand what an image is, what a container is, how to mount your file system into your Docker container that's currently running, and then figure out which volume to, like, all this stuff. It's complicated, but if you understand it, you can actually build some of this stuff. But not to digress, we were talking about GitHub Actions because GitHub Actions are kind of scary, complicated, and the documentation is a little bit obtuse because they come from the perspective of people who are used to the people who would go on a live stream and say that's actually called an OCI container. Basically, people who have expertise using the modern tools of web development. There you go. Not for someone like
it's not a hardware engineer who was afraid of Zephyr at first.
Yeah, like you could figure this all out, but it's not written from your perspective, which I found to be a gap. So I dug in and figured out some of the basics, and it's actually really straightforward once you move away from all the cruft. You have these events, so you can say on certain things, run this GitHub action. That's easy to understand. I don't know exactly what the 5-year-old framing would be, but when this thing happens, run this script. That's pretty easy for just about anyone. I'm having some weird rendering issues.
John, can you, for my old eyes, can you make the text a little bigger? I have old eyes.
Yeah, I'm wondering why it's actually rendering weird for my machine. Okay, let's try to. That better?
Yes. Okay,
and let's see if I can hide this. So there's lots of events you can. This is really. Are you guys seeing this weird rendering, or is it just my screen?
I don't know what weird means in this context.
It's like flickering. Let me try something else.
Oh no, I don't see flickering.
Ooh.
Switch over to the web editor. That might perform better, and also might zoom in better. Yeah, I'm still getting weird renderings. Okay.
Looks okay for us.
Yeah. Maybe because of StreamYard trying to.
Ooh, that looks really nice.
Yeah,
now I can really see it. I don't know what my excuse is. My eyes aren't old; they're just bad.
Well, hopefully, they stay. Yeah. Okay, so you have these events, and there's all kinds of events you might want to run this action on. For example, you might want this to run regularly. So I have a little scheduled job. So every day it runs this action. But also, if you push new code to the main branch, run this action, making sure looking for specific tags, lots of configuration. This is where if you start reading the docs, you get confused and you're like, I don't understand all this. But TLDR, you can run an action when something happens. And you have a bunch of jobs. Jobs are just steps. And for my GitHub action, we have one job with a series of steps. And I'm going to skip over some of this part. But basically, check out some code, set up the Docker tool to build, add some configuration so that we can upload it to GitHub. And then the last part is run this Docker file, tag this Docker image, OCI compatible image, and pass in some metadata. And so this now runs whenever there's, on a schedule, and it will build it for each one of these different architectures. And then we get the images you saw hosted on GitHub previously. There's a lot. Go ahead.
One of the things I was going to mention up there at the top, building images is a super common operation that we do in GitHub workflows. That's another. I'll throw in another pedantic one. I always call them GitHub actions, like what we're looking at right now. But this is a GitHub workflow, and like the things that you use are GitHub actions. But I have never once correctly referred to it as a workflow. I'm pretty sure I just everyone calls everything an action. But anyway, I feel like a lot of times because we use GitHub workflows to build images, one of the things that gets really confusing is you can also run your workflow in a container image. So here we have like runs on Ubuntu latest, which is the runner, right? Which is not saying like, here's a container that I want you to run this workflow in, but you can build an image in a container, right? Like you can specify that. So you can, I think our self-hosted, which maybe you'll be getting to at some point, is like, we're actually running things in the, like the build runner is a container, right? And so that's always something that I feel like is hard for me to like wordsmith when I'm talking about this and get confused on.
There's so many layers of stuff that makes this extra confusing. And the moment I started just to like not worry about some of the details until I had to, was I was able to make progress. Like this is a virtual machine, which we all know about VMs and VMware or that's the one that's open source ish. VirtualBox, right? Like it's taking this code, it's downloading the Docker file that I originally had, and then running Docker so that I can build this image. But it's all doing in a VM. So this is not scary. This is VM territory. Now, the second part of this story was actually using it at Goliath. So if I pull up another project, we recently open sourced a bunch of our reference designs, but more importantly, this reference design template. So if I pull up this, and it's the basis that all of our reference designs are built on. And we wanted to start using some reproducibility. And so that first thing was, I want to build images for the community, and this is helpful, and people have been using it. We also want to use GitHub Actions to actually build and test firmware for these reference designs. Again, scale, automation, reproducibility was the goal here. So I kind of skipped this part. The very first line of what is a GitHub Actions workflow. Thank you, Jen. You write a YAML file, and you put in this magical folder, which is under the root of your GitHub project, .github, and then workflows, and then anything here will automatically be run by GitHub Actions. And what we put together is a different type of workflow. This one is for compiling the source code in a reference design. This is a template, so it's actually not really functional, but you can kind of see, I'm gonna skip over some stuff and go back to it. We have a job called build. We have some steps, which if you're familiar with Zephyr, gets all the Zephyr bits. It initiates the workspace, downloads the Python dependencies, then it builds a board from that source code with a specific flag. And we do some copying files over, and then we create an artifact. And GitHub Actions has a place to store files. Just like if you're building it, you need to store it somewhere before someone can download it, and that's called an artifact. So that's the same steps I would have done if I were to have compiled some machine, except for storing it on GitHub with these artifacts, but pretty straightforward. And so now, because we've set this up, we have an event called a workflow dispatch. Basically, I can push a button and it will build this project, this particular example with a specific board in mind, which is from when we launch it already super useful. Let me pull this up. This is all public. With GitHub Actions, you can set it up in such a way that it has this manual runner. So instead of having an event like a cron job or a push to main, we can say run when I click this button. And we can pass in values. So we have the version of the Zephyr SDK, the name of the target board. And if I were to push this button, I would actually go through that whole workflow. And at the end of it, as an artifact, a zip to download with the 3 output files that we care about for testing and development, for usage. Do we have a release? I don't know if I have a test release here. No, because we reset it before we go live. But what Dan was hinting at was combining containers and GitHub Actions. Sorry, OCI compatible images and running them in containers with GitHub Actions. So that was the thing I skipped over. What this does, the last piece of this whole story, we built these examples in GitHub Actions, but instead of running the actual code inside of a VM, we actually, I get a visual, take that application code, run inside of a container. I'm assuming this is a Docker container, and then do all the build and all the other steps. You
gotta pause when you say container. You gotta pause and be like, Dan, container.
I know.
I can't see him, so
I've created some like minor like trauma, you know. Jonathan's mind.
So, now I'm self-conscious, but you know what? Every time I say it correctly, I feel a little bit of dopamine. Like
I will say so. It like there's trending towards correctness and then trending towards like what's generally accepted. And so the issue with like being more correct about this is now no one knows what you're talking about, but like the people who are really pedantic about it are like, oh, like great, but that's like 1% of the population. Everyone's like, just a Docker container. Settle down.
We're among nerds. I find that is a good way to filter people to find your kind. You know, like if someone at a vet, calls it a piece of electronics or a PCB, you're like, oh, someone said PCB, they might be, cool. All right, I feel like I don't want to ramble too long, but the kind of key unlock here is because we're running this action inside of a container, it's even more reproducible, and we have some better guarantees of the environment. Like a VM, we don't know exactly what's running underneath, and it's a whole other conversation, which Dan is more qualified to talk about. But we wanted to do a few things. We wanted to be able to build our example projects repeatably and reliably and fully in the cloud, so we didn't have to worry about it worked on my machine or I had this version of pip installed. We wanted to be able to do it scalably. So there's some advanced stuff in this GitHub Actions. So we, for example, can build for multiple targets. And then we also want to be reproducibly. I don't know which of the 3 things I listed, but that's why we want to use containers and run the actual build step in containers. And I'll show this. I'll go back to this again. Like this workflow is 67 lines. And the amount of time back Mike from our team alone gets from just having this in the cloud is very measurable. But the kind of relief he has that he doesn't have to worry about building and then pushing it somewhere and accidentally like doing something weird with this environment that could brick the example is far outweighed by the time. But it's
I was there for that, actually. That was the release process. We were doing like a release party. And it was like, all right, well, the only thing you have to make sure is that you're actually compiling the right thing right now. Because the one step that you can get it wrong with is like, I'm compiling it on my machine. And if I put the wrong thing in right now, or I put it to the wrong, like I put the wrong version number on it, like, ooh, yikes.
There's also sorry, go ahead, Jonathan.
I was going to say like, there's been some pretty scary security issues with like things like package managers that it could not be your fault, but someone does an attack on pip, not to call him Python, and you have no idea. And you're just like building your application, and everything looks like it's cool, but there's Monero crypto mining stuff. So there's some level of like cushioning with the way when you move to something like a container, a Docker image. Now I'm confused. I don't even know what to call this thing anymore. And we just like don't have to worry as many things because of this setup.
Yeah, I feel like there's there's a number of layers. You went the exact direction I was thinking as well. But there's so many layers to like supply chain aspects of software. But one of the things that's really important and we try to model with our use of containers is using content addressability, right? So moving away even from, we use tags in a number of places, especially if it's, maybe just some CI or something like that. But if you're building an artifact that's meant to be deployed, which is kind of talking more in the cloud context, but I think more and more as you and Mike and Chris and Sam and, all of our firmware focused folks start to move more towards building firmware and building artifacts and potentially, like building OTA releases and pushing them to Goliath and that sort of thing in tools like GitHub Actions and GitHub workflows that we can start to also have a lot more guarantees around supply chain security for firmware because I feel like, maybe this is somewhat of like a biased opinion, right? But I feel like it's lagging a lot of times behind best practices for, cloud deployed software and that sort of thing.
I don't think it should be like the value that our team is getting from some of this automation already is like measurable, but I always like to talk about the impedance mismatch between the world of cloud and the world of hardware. Like the knowledge and the documentation and the tools are built for a Java application engineer who works in an enterprise and not a firmware engineer who's like got a dev board plugged in and trying to figure out how to build this. And so I think it's one of the reasons why I'm a little bit passionate about trying to get some of this knowledge, the rest of software, because it can be used. Like this is exactly what we needed, and it's protection, nothing custom. It's just how GitHub Actions works. And so there's I think the technology gap has been there and it's closing, and now it's a knowledge gap, and sharing information is the only way I know how to do that.
I lost Joe there for a second, but I think I got the gist of it.
I think that's largely what I want to share on GitHub Actions. Like my plea is anyone who's doing embedded software, like check it out. It's like actually pretty straightforward. Whether you use GitHub or GitLab, there's a lot of even alternatives to those, and automate your firmware. It will save you a lot of headaches. I guess the last thing I want to kind of allude to some future development. These examples are part of our open source effort, and people use them. We are now, and we've been investing a lot in automation on our actual firmware SDK, and we're hoping to take some of this automation and actually bring it to our SDK release process, which is pretty exciting because we've gotten so much value on our example projects and our reference designs. And once we have that, some of those benefits of supply chain reliability and other scary bits, we can also address with Actions. So that's my little spiel on GitHub Actions.
All right, let's talk hardware because that's much more interesting, right?
Well, there's only one place to start for hardware, Chris.
Where's that, Dan?
And that is, how does one pronounce KICAD?
In 2023, I am trying to say KiCad despite my brain's absolute disgust with saying it. I've been trying, man. I've been trying.
So we have the CEO of Goliath on this call. So I just am wondering if we can take an official company stance on the pronunciation of this tool.
Need to do that. I don't think we need to do that. Okay.
I'm just trying to generate some controversy for more content, right? Any publicity is good publicity.
Is it Ki or Kai? Our hardware expert is also an evangelist de facto for that piece of technology. So I think he's more qualified to give an opinion.
like I said, I'm trying in 2023 to try and fold into the rest of the crowd. And now I'm getting some gruff from Dan for it. So just saying.
No. I am glad that you are. I believe you're switching to the developers of the tool. That is how they
That's
refer
right.
to it.
Because it was yes, that's right.
Yeah.
You
So
know
if
what's
you
funny?
make it, you should get to decide. That's my policy.
No one
Got
says
it.
like Egel or
Well, that
Ultium
one's a little more straightforward.
or Yrket. Like imagine umlaut.
No one says
All right.
GitHub.
All
do
right,
they?
this is not a linguistic chat. This is a hardware chat. Let me try and shortcut this whole conversation here. If I can find it, you guys put me off my game. I got to say,
That's what we're
I'm
here
sure my
for.
3D
You're the
renderer is working.
professional, but we're professional at
Peanut gallery.
sidetracking. So
Yeah.
Got it. Wow, I crashed KiCad right there. I think having StreamYard and this stuff at the same time may have stressed it out.
We need to get you a dedicated streaming machine and a capture card, and then
That's what it is. Yeah.
and then you'll be good to go.
Yep. All right, pulling it back up here. All right, there we go.
It's a cool background, by the way.
Thanks. I stole it from the James Webb folks.
I think it's open, royalty free. What's free?
Yeah, I don't know.
We paid tax dollars for it.
We're gonna get what is a DMCA takedown on this video from NASA.
All right, let's see if this renderer works this time. I'm not sure it's going to. Looks like it's not having a good time here.
Yeah, I think I was seeing some like GPU flicker when on my end when I was doing the screen share.
It's working on it.
It is.
Anyways,
what this is the front panel that is on here. I can.
Do you have any finished reference designs? You can just like see the whole thing.
They're all taken apart right now, but it's
like
effectively this. Is my video still working?
Yeah.
Yep.
Yeah, this is definitely crashing my computer. So anyways, this is so basically this is a PCB front panel with some touch, e-ink. Oh, come on.
What if you try to stop screen sharing while you're rendering and then?
Wait. There we go. I think it's trying to do realistic mode. No, it's not. You're not in realistic mode. There we go.
It's ludicrous.
All right, so this is, yeah. So this is a pretty simple board. This is a Raspberry Pi Pico, some backfiring LEDs. This is a quick header. This is the driver circuit from. This is actually we learned this from Pi Maroney. So basically, the from the RP2040 Badger. This looks very similar to that. This missing part appears an inductor, and so basically all it is you're just driving a type of e-ink display, which then shines through here. You see there's a couple of buttons on the front panel. These are cap touch buttons that are controlled by this chip in the upper left here. This upper left here. And yeah, they're despite, oh, there you go. Despite simplicity of this board, I still had a couple mistakes, as does happen with hardware. And so I thought I could go through and show some of these, show some of the mistakes here and show some of the fixes. I thought I was going to be able to do that. I might actually have to bounce in a couple minutes because my scheduling was a little off. But I guess in the meantime, I'm showing some hardware and I'm talking about what we will be doing here. One thing is we obviously have to change the logo down here. So that'll be one thing I'll do. And maybe in a future stream, I guess I can go through and update some of these things.
You have to drop now. Are there more things? Can we ask questions?
You can ask questions. Yeah, I think I got about 3 minutes.
Can you tell me about the driver circuit?
The driver circuit. Yes. So on the header here, it's basically a SPI device.
Mm-hmm.
And then there's a busy signal, reset, and then a couple of, these are all power supply rails basically here. So these are just capacitor, like decoupling capacitors on the other side. And so you give it 3.3 volts on the actual display itself. This one's, yeah, here we go. So the display itself looks like this. It's out of its packaging. Oh, that's Dan.
Hello.
Hello. So it looks like this. And this is actually like chip on glass. And so it's a very, very, very tiny little silicon piece back here. And just a flex to that. There's a stiffener. And then it's e-ink underneath the glass. And so that's all it is, really. Did that answer your question? There's not a lot going on. Yeah.
It did. I was this is the is this the part that we're driving with the so we're using SPI for this, right? From the RP 2040, and are we using PIO or just the dedicated SPI?
Just dedicated SPI on this one, yeah.
Gotcha.
Yeah. So the reason Dan's bringing up PIO, we're actually using a PIO for the I2C coming into this. So the whole board is actually an I2C peripheral. And that's kind of what's a little bit different about this setup is we wanted to have a device that, we didn't know what was going to be in these boxes. So most of the time it's NRF9160 running Zephyr, but it just as easily could be an ESP32. It could be a whatever. And so we wanted to make it so that it's literally just a register that you write to. So you pass it. You could set up different slots, basically. Excuse me. Oh, live stream. You can set up different slots, and then you just write to those slots, basically, different readouts that you have on there. And if I get out a board, I guess I could show it live and in action. And so each slot, you can then name as well and say, oh, this slot 1 is temperature, and slot 2 is latitude, and slot 3 is longitude. And so let's see if we can turn this on. So this is, there's also stuff about this on our blog, of course. I'm not sure this is going to be visible, but there's you can touch through the touch screens here, and then there's a summary screen as well. The reason we did all this stuff and the reason we did e-ink in the first place, like why even bother with e-ink? Well, the thinking was the baseboard, the thing that's inside the case, is very likely to go to sleep, and we still want some relevant information to be up on the screen. So the whole box go to sleep. You want to actually power down this entire display. So you cut off 3.3 volts to this display as well, but you still have relevant information on the screen. So that's really the thinking there. Not to mention that, industrial style things often are in outdoors, high sunlight environments, and visibility is often an issue. So that's really where we started looking into e-ink. E-ink's kind of its own bear to work with, but it is possible. And so basically we have an e-ink kind of I2C peripheral that then you can post things to from an embedded device. Low power embedded device.
Is the thinking about the sleep scenario you were just mentioning there, the device could wake up, let's say write the temperature or whatever, and that can be shown on the screen. They can go to sleep and that will stay there, and maybe it'll wake up every so often. So the temperature would be a little bit stale, right? But it's updating it. It's within the last 5 minutes. Let's say it's waking up every 5 minutes or so, but the screen continues to display that. Is that kind of the idea there? Or?
Yeah, exactly. I mean,
yeah,
you probably wouldn't want to do it every 5 minutes. I mean, that would be pretty costly in terms of even just updating the display. But yeah, it's basically there's certain classes of displays that can do kind of persistent. There's another one that Sharp makes. It's kind of a capacitive style that was on the original Pebble. So that's kind of like a low power display. And there's been other stuff in that space, but not quite the same level as e-ink. And e-ink has been dropping in cost as well. And so that was kind of our interest there. We also used to use a board called the MagTag that Adafruit makes. And so we were very interested in that. It's a fun little display project as well. But that just persistence in a completely off state, I think, is the interesting thing there.
That's cool. And why well, maybe you might have to go, but I'll give you this question. You can leave it on a cliffhanger if you want. Yeah.
Yeah.
So why are we using SPY to talk from the RP2040 to the display, and why are we using I2C to talk from whatever this is a peripheral to? Yeah.
So the reason SPY, because that's what they give us. Whatever the vendor tells you, that's what you do. And the reason I2C, because we have other stuff on the baseboard. So if you look in the project page, oh wow, my whole computer's slow. Yep, nice and slow here. That's a good one here. So cold chain. So inside this box here, we had already had other. You see, there's other I2C, these quick connectors from SparkFun, which are just two I2C pins, 3.3 volts, and ground. And so, wanting to be able to cut the whole thing off, we then just power down the connector itself, and that cuts off whatever peripheral it is. Often, we're trying to maximize for flexibility. That's why we use these click headers. And we have also used other off-the-shelf sensors in the past. And being able to just power the whole thing down is one way, especially in an off-the-shelf scenario, is one way that you can ensure that you have zero current draw there.
Cool.
And with that, I do have to bounce. But I'm sure Dan has many interesting things to show on the rest of the stream.
Well, we'll see. We will miss you.
Thank you for coming to my TED Talk.
Hopefully, it doesn't end the stream when you drop, but we'll try it out this
time.
time.
It shan't. You will. You'll be able to.
Perfect.
It shan't.
Shan't
away, good friend.
Well, I'm kind of disappointed because I was hoping that. So I already, as I mentioned earlier, got coffee with Chris this morning, and did my usual. Let's see how much information I can extract from his brain in this hour. And I was thinking we were going to get to do that again, but cut short.
I talked about GitHub Actions for too long. I'm sorry.
No, that was wonderful. It's just, Chris, for some reason, can't spend his entire life on a live stream, which seems pretty unreasonable to me. But one of the reasons why, maybe something interesting for us to talk about is one of the reasons why I'm very interested in what Chris was showing off there is because I'm attending my first SuperCon next week, which I'm very excited about because there are lots of Goliath folks who are deeply embedded in that community. And you've been before as well, right, Jonathan?
Yes. I had the privilege of speaking at the very first SuperCon.
Ooh.
What'd you talk about? A bazillion years ago. What did I talk about? I talked about motors and motor controllers.
I remember that. Yeah.
And I was excited because I got I got a chance to speak at an event for a company that I really enjoyed. And they're like, it's the first time we're taking different talks. And so I wrote some stuff before, which was why my talk got accepted about robotic things. And it's like I have a little bit of an imposter syndrome. And literally the first person to go on, I was the second talk, was like shooting lasers from space with high precision gyroscopic control. I'm like, and we're going to talk about robots and toy projects. And I felt, but it's a great community, and I think you're going to have a great time as an attendee.
I am very excited. But they did announce the badge, which has this been kind of a thing since the first SuperCon, or was it developed afterwards?
I don't know if the first one, from the very first one. There's a whole subcult called Badge Life. And it really came from DEF CON. So the more of the hacker community, and it's using PCB badges to be interesting. For the longest time, they're just blinky, but they're cool designs. I don't think I can post the chat. But if you Google Badge Life, let's see if I can find some. Well, not the Badge Life. Maybe we should filter. If you go on Hackaday and filter for Badge Life, you'll see some really great Let me see if I can join the chat. Yeah,
I've got the tag badge life from Hackaday here. I'll drop in there.
Yeah, if you're logged in, I'm not logged in.
Thing here.
Perfect. And it's like now a whole thing. At the time, that's when badges and the idea of PCB-based badges was really coming onto the scene. And so for the very first SuperCon, I want to say Chris, but I know a lot of people at Hackaday worked on them. And now it's this whole production. They're super complicated. And one year they had like an FPGA and a custom computer on it. And they're collector's items. People pay for the like DEF CON ones. Some of them are pieces of art, literally, and people spend hundreds of dollars to buy one, and even more if it's more like exclusive badge. And so the badge at SuperCon is a big part of the event.
Yeah, and they announced the 2023 one, which let me grab that and maybe we can pull it up here. I was impressed with how cavalier.
Oh, did your internet go out? Are you still on the stream? I don't hear you. Well, folks, that might be the end of Dan's live stream. Apologies. Yeah. Sam, can you see me dancing? Your comments are the only signs of life I have. Should I show more GitHub Actions? Anything cool? I got my 3D printer working again. I'm printing a Halloween spider. Well, a spider for Halloween. Yeah, there you go. Thanks, Sam. I had to recompile firmware for this 3D printer to get it working again, and it like probably doubled the quality just by using more modern version of Marlin. That was cool. It's kind of lonely to do a live stream by yourself, talking to yourself, and don't really have an agenda. So
I'm back.
There we go. I was literally tap dancing. Was off camera, but
perfect. So I have this is like not something I feel like ever happens, but I actually have a wired connection. I have an Ethernet connection to my laptop here, and it apparently failed. But if I turned it off and just went onto Wi-Fi, I'm back. So we'll stick with that for now. But I was gonna pull up here the let's see if I can share. Let's see if that looks reasonable. Yeah. Okay. So back to the SuperCon badge. So they announced it, and this is it. But Chris was just talking about the RP 2040, which is right here on the back of the badge. And there's a lot of, that zoom in didn't work, did it? But it's right here on the back of the badge. And so some of the things that we're doing on that faceplate that Chris was showing off are similar to some of the capabilities of this badge. And I think we talked about PIO a little bit, but PIO basically allows you to take some of the pins and kind of like implement a it's somewhere between like an FPGA and bit banging for an interface you can add there. So it has dedicated hardware controllers for things like I2C, and I think it has 2 I2C controllers and 2 SPI controllers. But then you can also add another I2C controller with PIO if you want to, and they're doing some interesting things with PIO in here. So anyway, we have been thinking about some of the ways that we could leverage that existing firmware to also run on this device. And so I've been kind of peppering Chris and Mike with some questions about that. And part of this was not today, but earlier in the week, I went to Chris's house. I showed up at his house, and he gave me some of these RP 2040s or Pico boards that have the RP 2040 on them. And so, as you can maybe tell from the having two of them, we're interested in how we can use one badge with another one. And there's obviously Goliath bits in there. So should be some fun things. Very excited to see other people's hacks and potentially our own hacks as well.
So let me, has Chris or Mike or both given you tips to have a successful SuperCon?
They haven't given me the full rundown. I'm staying with Mike. And so, he'll obviously be my guide throughout the whole weekend.
Yeah, SuperCon Sherpa.
That's right, exactly. And he is obviously, the celebrity there. So I'll just be his entourage is what I'm planning.
You obviously be Turtle. Entourage reference.
Obviously.
So I'll give you this tip, and they might give you the same. There's like a lot of like hardware hacking. Maybe some people just go there for socialize and talk about hardware and also just hang out with nerds. But there's also like scheduled hardware hacking type stuff. The badge is one key cornerstone to that. So at the end of SuperCon, there's like an award ceremony. And there's usually a challenge, and whoever gets the most points of the challenge, like last year was crazy. I just could not even start it. But oftentimes it's involved adding some hardware to the badge that doesn't have. And so in the first year, people were like added extensibility to a board that didn't have it in very creative ways. But now there's more formal ways of like, here's a documented ISA for the, the chip and where you could put additional peripherals. Like that's how crazy it was. But bringing some bobs and bits actually with you, especially that's why they're releasing more details about the badge early, so that you can add like, I don't know, some sort of networking interface between two boards and figure out like what you might actually need, mechanical interfaces or PHYs or things like that. They also have hardware there too, which is nice. But bring some, if you have some ideas, like just stuff in your kit bag to potentially use as part of a fun hack. That's one.
We are certainly doing that. In fact, there might even be some Goliath hardware that is in that bag. So should be fun. Also this year, I don't know, maybe they had this in years past, but it sounds like maybe a response to what you were describing there. There is a like companion breakout board for the badge this year.
No, that's definitely new.
Yeah, so it's just like an array of through hole. And so yeah, they're definitely expecting folks to extend it this year, which is cool.
Yeah. What else? I don't know.
I have an ask for some advice. So my question
that was
is,
the question.
Yeah, I do have an ask, and here it is. A question for my question. No, my ask is, so I'm very interested in the hardware hacking sessions because that's really fun, and also you can just like learn a bunch, especially if your background is not in hardware, right? So I'm super interested in just like being around folks, seeing what they're doing, maybe potentially winning a prize for Goliath and showing off some of our capabilities. Not in a commercial sense, and purely a hacker's mindset sense.
Hacker cred is worth more than any
exactly
monetary prize.
I actually got a mortgage on our house with hacker cred recently. So,
that's a different story.
Yeah. No, we don't have a house, so not a true story. But no, my question was, so I was looking at the lineup, and there's a lot of folks that followed for a long time, on the internet, if you will, as well as some folks I've never heard of that have really interesting talks. And so my ask for advice is around what would be your balance between attending talks and spending time hacking on hardware based on your experience?
That's a good question. The nice thing about conferences, and particularly with SuperCon as well, like everything's recorded. The things that are not recorded are workshops. So if you, I don't know if they're still doing workshops this year, but those were always sold out pretty quickly. If there's a particular workshop that you want to go to, I would prioritize that first, because like having hands-on the session, you just can't replace it. Like literally I've only gone to 2 workshops in all the years of SuperCon. One was from the creator of the Blackmagic Probe, which is a device debugger. Super cool. Also super nice guy. And I bought it 3 months before, not knowing about the session, and then I actually learned how to use it in the workshops. Like, this is
nice.
great. And the other one was the one that Chris and Mike ran.
Nice.
Around Zephyr. But like, those were both, both very valuable. There's a couple like shouldn't be missed speakers that are pretty famous at this point. So like everyone attends it, and it's usually in standing room only. And so Mike will tell you which ones are likely going to be those. So I would make sure, if you're going to do a workshop, prioritize workshop. Go to the couple ones that we know are like, that Mike recommends. Is like, oh yeah, this is going to be a good talk, and then just spend the rest of the time in the hallway track, as it were. That's where I get most of the enjoyment from. It's just like talking to other people and waiting in line to get tacos, and you hear about some crazy stuff these people do in their day job, or stuff they don't do in their day job, but it's a fun project. It's a small event. It's like only a couple hundred people, and you kind of can talk to every single person if you really wanted to in the few days. And I think you'll enjoy that part more.
Yeah, absolutely. I know. So one of the workshops this year is Matthew Venn is doing a tiny
nice.
tape out workshop, which is awesome. I've definitely been following that for a long time. There's also there's another workshop from someone quite notable, but I can't remember who it was. But yeah, there's enough quality talks that there are some that I know I won't be able to attend both of because they're at the same time. So
yep.
But it looks awesome.
Yeah, I'm looking at, this is a great lineup of talks and workshops. So the one talk I always try to make, if he's speaking, and he's spoken every year, is Jerome Domberg. I'm not pronouncing his name correctly, but he's very famous in the Hackaday world. His internet name is Sprite_TM.
I've been to his site before.
Yeah, his day job is like an engineering manager at Espressif, the makers of the ESP32 and family. But his hacks are just insane. And my favorite talk, probably the one that I reference the most, there's a whole community of people who are really into Tamagotchis. And actually, there's been multiple Tamagotchi talks at SuperCon, which is a whole other rabbit hole. But he was playing around with an emulator for Tamagotchi, and that's Sprite TMs. And I think he decided to write his own emulator for fun, and then put it on ESP32 because, of course,
right.
I mean, an ESP32 is significantly more powerful than the Tamagotchi, so that's easy for someone like Sprite. But then, because he wrote an emulator, he put it on like an x86, like on his laptop. And he's like, what would be fun if I actually put it in the cloud? So then he created a Tamagotchi farm with like thousands of Tamagotchis all running in simulation in like an AWS instance, and like interacting and up leveling. He found bugs in like the actual Tamagotchi code and weird like scenarios that Tamagotchi super fans are always trying to get to. And he's like, oh yeah, let me just increase the virtual time and have all the Tamagotchis have babies and fight and get married and all that stuff. It was a great talk. Let me see if I can find it's what's cool about him, and I think other sort of engineers who are online,
Mhm.
is not only are their project impressive, the way they communicate about the project is also something that I admire. It's
Mhm.
enjoyable, it's approachable, and you can be in an audience where you have PhDs in electrical engineering and web developers who blink their first LED with an Arduino, and folks like Sprite can really speak to everyone, which is super cool. And yeah, you can go after him and chat with him about it, and he's happy to chat more.
Yeah. Yeah, that's awesome. It is a very special skill set. One that I feel like I am trying to learn from folks like that, of having deep technical knowledge, but also being able to communicate it in a way that's like uh, not skimming over the details, but also like making it understandable, you know? And it's easy. I feel like it's easy to fall into sort of like a metaphor soup when you try to do that, right? And then you end up not even talking about the thing. But some folks are just very talented at kind of like weaving that all together, which is awesome. Um, but yeah, I know there's a few folks that are like internet folks that like that, who I'm excited to meet, and so should be a lot of fun.
Yeah, and not everyone can go to an event like this and travel. Some people around the world. The talks are online, which is cool. But I think my favorite part was like talking to Sprite afterwards, and like learning about new things, and meeting some of your internet heroes, and then showing what you've done, and then like, they're like, oh, that's super cool.
Absolutely.
I would say that the two people that I enjoyed meeting the most last year was well, I met him at the one before that as well in 2019. Scotty from Strange Parts. If you know
Mm-hmm.
Scotty, he's the guy who built the iPhone from scratch, and he his channel Strange Parts is awesome. Super nice guy. And then I think he's also a speaker. He's the creator of the Oculus place.
Is that the pick and place machine? I want to say that he's not, that he spoke last year.
Yes, he spoke last year.
I
The
saw
Lumen
him on.
PNP.
Mhm. I don't think he's there this year, or he's not. I don't think he's speaking this year.
No, if he's there, you should take the chance to talk to him. He's a super smart guy and super nice.
Yeah, I did have a brief period of trying to convince Chris that Goliath needed a pick and place machine, and he was not amenable to my request.
Well, but he may have asked me too.
Yeah, right.
Maybe one day. But in the meantime, you can learn how to hand solder.
Right. Well, that's what I've been doing. I think I mentioned this today at our I like doing our internal demos and also live streaming on the same day, because you just like come out of those full of inspiration. But Chris gave me these Picos without any headers. So this week I was soldering the headers on, but I sent macro pictures of all of my joints, and had Chris and Mike grade me on my soldering work. So
it was like, if anyone remembers Hot or Not, but like flowed or not. It's like, did this flow well?
Yeah, that's the we're rebranding the stream actually to flows or not. There's probably even a better word for
Yeah.
I don't know, like joined or not, or something like that.
Yeah. I remember there's a bunch of meme like alternatives for rating people. My favorite one was robot or not.
We do that today with we can do that with all the AI generated content.
That's so true. That's so true.
Yeah. I think there actually is a site that's like shows you two pictures, and it lets you pick if one of them,
Soldering.
which one's AI generated. Yeah.
Oh, I thought you meant the soldering one, because I'm like,
Oh no. No, that would also be fun though.
So speaking of soldering,
Mhm.
I want to say like 2015, I took a soldering course, or sorry, an SMT course, which was super lucky. And it was actually at Hackaday by one of the Hackaday employees, but kind of on the weekend. And what I learned is like surface mount is not scary. It's actually very approachable. And there's two things I learned, which now I'm like, oh yeah, I know. Yeah. You want to learn a surface. One is just good solder and lots of flux. Like the actual products you use matter. Old solder is terrible. Don't even waste time. But like, just put a lot of flux. And the second one is even the world's cheapest microscope. Once you learn how to actually solder with a microscope, like I'm talking about like a Fisher Price, kids bright colored microscope you might buy for a 3-year-old will actually help make you a good hand solderer for SMT. And so we did have high end equipment at the training session, but like once you can like disassociate the looking through and doing it, I mean, I was doing tiny SMT parts, and there's like this there's a kit you can buy called an SMT challenge. They actually do the SMT challenge at SuperCon.
Oh, nice.
With like alcohol, so it's even better. But you can get these kits.
Microscope and alcohol, they cancel out actually when you use them both when soldering.
Well, we're talking about 300 degrees Celsius soldering irons is actually the first order problem. But you get like a series of smaller and smaller components, and just like a little like they're throwaway PCBs. They're I think they maybe have some LEDs so you can feel like it's useful and not actual junk, but you can practice. And man, once you learn how to, it took like, I don't know, 20 minutes of practicing, and you can start getting comfortable with it. And then if you ever use like a high-end microscope, you're like, oh my gosh, I could literally do O2, whatever's by hand, which is impressive. Now you can, and folks like Chris who've done that, they're too often like, that's why we have a fab house.
Right.
It's pretty cool to like, I could actually design my own circuit and get all the surface mounts and flow it, and I don't have to wait for assembly and pay for that and stuff, which is a neat superpower.
Yeah, I was telling Chris this morning that I really like. I mean, I spend a lot of time on the computer, and I really like soldering because it's like if you were doing woodworking or something like that, or like welding on a very small level. But then like after you do it, then you have like a computer, you have like, an electronics part that you can maybe program or do things like that. And I feel like that it feels very like connective to do like a physical thing to enable doing like a digital thing. I don't know. There's just something about that I feel like is so much fun. I haven't gotten to the place where, I haven't become jaded yet, like Chris, to where I'm like, I don't want to do that. That's just a task. It's still always like super fun for me. So.
No, it's more like if you have 300 parts on your reference design and you need to make 10 of them, and it gets a little tedious.
Right.
So Chris is not jaded. He's just got a lot of things to do. And honestly, like the cost for assembly has gone down so much. It's just wild. Even domestic assembly is approachable for a hobby project, which is crazy. Crazy to think about.
Right.
Yeah. And you can get a low-end microscope. There's a lot of like the clickbait on YouTube is, here's a cheap electrical engineering tool that's almost as good as this 3000 version. Like if you ever used a Metcal soldering iron, those things are like, you feel like Harry Potter, how precise and light the soldering iron is. And you can get like, this is a Metcal knockoff for $200, which is cool.
Yeah.
They have these really inexpensive microscopes, and it's not comparable to like a professional microscope for rework or whatever, but like $50, $75. They have decent zoom. Clearance is like one of the bigger things you care about. But then it has like a little LCD display, because like LCD displays are super cheap, and so you can pretty much do surface mount as a hobbyist for $50 with that and a decent soldering iron. You don't even need a Metcal.
Yeah. I've been I have the the Pine Sill, which
Ooh, yeah.
I've been using, which is really nice because it's USB-C. So just plug it in. But yeah, I was a little concerned if it would get hot enough for lead-free solder. But it had no problem. I've been super impressed, and the firmware is open source, which is really cool. So you can like mess with that if you feel so inclined. But yeah, it's been great, and I think I want to say it was like 30 something dollars.
Ooh,
So like very portable. So yeah, I'm gonna bring this with me actually to SuperCon. So I know they have gear there as well, but yeah,
that's
super
so
super
cheap.
nice.
Oh my
Yeah.
gosh, I have the predecessor that's not by them. And I think I paid $100 for it. So
Oh yeah, the T whatever, is that what it
the
is? Say what is?
TS100,
Yeah, yeah.
the non USB-C one. So the only thing you're gonna run in, the only time you will run into issues,
Mhm.
is how much thermal output a soldering iron has.
Mhm.
And so like, I mean, a PCB is just a piece of metal, right? And so the larger the pads or
Mm.
other factors, right? Um, a soldering iron might not be able to output enough heat in order to actually cause
Keep
the
the
solder to
yeah.
flow. Um, which is great for like embedded electronics, microcontroller kind of stuff, because you have you actually have smaller foot pads.
Right.
And folks who do like analog audio or power electronics, where you have these humongous pads deal with all the current, those would not work. And they have like these humongous soldering irons. They're almost comical
Yeah.
uh, for putting together electrical wiring and stuff like that. So that's where the excuse me, something like a higher end, higher output soldering iron actually makes a difference, because not only do you have to output all that heat, you have to do it quickly, because otherwise the flow doesn't work. But like, I don't think you'll ever run into that issue with the kinds of stuff that you're doing or want to do with headers and surface mount
Right.
ICs.
Yeah. It's I'm also trying to take the approach. We are comparing soldering irons to uh cameras, like mirrorless cameras, and that you always have this like notion in your mind. I think cameras are way worse in my opinion, or at least they are for me. But like you're like, oh, I would, go take pictures at this thing, or I would make a video, but my camera's not nice enough. So it's not really gonna be that cool. So I need to get the nicer camera. But then like you just do that forever and you never actually use a camera that you have. It feels like a lot of equipment for soldering or whatever electronic stuff is the same way.
Guilty.
Yeah.
3D printers. I keep on wanting to get a nicer 3D printer and a better, faster one, and I haven't been able to justify to myself, let alone to my wife, that I need a $1,500 3D printer. And I'm like, oh yeah, if I just actually use the one I have until it is no longer a suitable tool, then I should upgrade. So that I've been trying to actively not fall into my normal purchasing, that trap.
Yeah, yeah. I have held off on the 3D printer, but I'm very tempted. I do have multiple friends in the area who have 3D printers, which makes it a lot easier. And uh, I've also moved like every year since I was 18, so that also helps. You have this dread in the back of your mind. You're like, if I bring this to my house, I'm also gonna have to take it out at some point. So
Yeah, I for me, 3D printing is more of a hobby than it is a part of my day job as CEO. I barely get to use it. But when we've actually had some 3D printing stuff done. Chris and other folks on the team get things made, but like we wanted to get an enclosure made, and so we had someone design this enclosure for us, and they just used a 3D printing service. Xometry, I think, is the one, and it's like he had access to a low end 3D printer to do a test fit, and then just like use that service. It is one of those things where you could do it at home, not like hand soldering, like maybe
right,
for one or two or whatever. But we had 10 of these to make, and it's very affordable and
Mhm.
higher quality than anything I could actually afford in my house.
Yeah,
So I feel like it is not necessarily something everybody should have, especially if you actually want to do it professionally or nice. Just outsource it to your friends or uh oh, nice. Yeah, Xometry is great. There's
yeah.
also there's one a lot of makers use, hobbyists here in the Bay Area where I live. think it's Bayer, Shibako. They're more for artistic projects.
Gotcha. One of my friends here who has a 3D printer works also at a 3D printing company here. But they do I'm gonna butcher this, but like they 3D print metal things. So it's like very I think they like 3D print like rocket nozzles and stuff like that. You know, it's like very intense stuff. So
I can see you going from like not justifying having a 3D printer to get like a 3D printer that can print rocket nozzles, just like full throttle.
Yeah, that would be very on brand for me, I think. That makes me think, have you ever watched the YouTube channel BPS Space? Or maybe it's BP Space. I'm not sure.
Yes.
It's like this guy who makes he basically makes kind of like scaled down versions of SpaceX rockets. Or I mean, I guess like, you know,
Joe Bernard.
Yes, yeah. I really like that channel because it feels like very full stack, I guess, because he's like 3D printing parts for the rocket itself, but then he's also like making the PCBs for the flight controllers, and you know, he's programming them and that sort of thing, and also he's like making cool videos. And so I'm like, oh man, this is just a confluence of all the things. But you also look at something like that and you're like, I can see that he's been doing this for like 7 years now, and he probably didn't have all this stuff when he started. So maybe just like, you know, get busy building something, and then you can buy more gear.
Well, the sort of the patron saint of makers, Adam Savage, always says you should start with the tools you can afford now. And I forgot what language. Great book, by the way. Every Tool is a Hammer, I think. He's like, basically, you need to get to the point where that tool is no longer useful. Like you've outgrown that tool. It's like, don't buy a super high-end commercial drill. Get the cheapest one that you can afford. You know, in the US, we have Harbor Freight or Amazon for $30. And then when you find the way you use that tool, and you're like, oh, you know what? I'm actually not getting the performance I need, or I need an attachment which just can't do. You've outgrown that tool, and then you should upgrade to the next tier of tools. Says the person who has literally every tool ever made and like collects high-end tools. But it kind of rings true, like that forcing yourself not to think the tool is the solution for your lack of skill or experience, which is my problem.
Yeah, that I would like to for like the holidays this year, make something that I can give to like family members. So I don't know exactly what that is, what it would be, but I've thought about like you know, like a macro pad, like a keyboard that's like a 3x3 array or something like that, that's programmable, something like that, that's like, oh, it could actually be useful. You know, they might use it for some sort of like shortcuts or something on their you know, laptops or whatever they have. But yeah, I've been thinking about like something that it's like low stakes, but also, you know, is actually making something. So
yeah,
that would be cool. We've also, I mean, I feel like I've said we need to get Mike on here to talk like 17 times on this stream, but Mike loves keyboards a lot, and
keep life.
Yeah, keep life, exactly. And so I've been, you know, just inhaling his knowledge on all of that. And we were talking, how cool would it be if everyone who joined Goliath got a custom Goliath keyboard that we had designed and made, and maybe even, you know, like you could even do like the me paper thing on like the microcontroller if you had a little LED screen on there. You know, like we could really go crazy with it. But I haven't heard of another company that does that. That would be pretty cool. Also high effort, so lots of our weekends might be taken up with that, but could be fun.
Yeah, and did Chris show the MagTag board? He flashed it maybe.
I don't think he actually pulled it up.
Since we haven't shown hardware in like too long because Chris is gone.
Yeah,
fine.
Yeah, we have one of those signs actually in our virtual office, our gather town. That's like how many hours since hardware was shown. And if it gets too high, someone grabs something from their desk.
Yeah. So this is e-paper in a weird state. I don't know why it's so jaded. I should probably reprogram it. But for a while, this is actually, since we're talking about badge life, an official badge from Adafruit. They've come up with a few other ones where it was actually meant to be worn. This particular one actually is meant for a refrigerator magnet. That's why I call it a mag tag. But we 3D printed a backplate so we could actually wear it. But ESP32, S2, some buttons, lights. This may have accelerometer or something. But what's cool is also has a battery and a battery charging circuit. And so this is before we started making our own hardware like the Astentis, the display board. And we were actually giving it to all employees. One, because we work really well with Espressif, but because of the built-in display, battery, and buttons. And we had some fun demos and some use cases. But 1 year in our annual hackathon, Mike, who is our display guru, no doubt, got the display working with Zephyr and Goliath. And we blogged about this. This was really fun. Created a program called Me Paper, like a concatenation of meme and paper, because he also wrote the service and a Slack bot. He went to town, where we could push memes to anyone with a Me Paper board. And so during the hackathon, actually, this was the next hackathon. We split the company in two, and we're hacking, and we're pushing memes to each other as we're working on our projects. And since then, before then and after then, we use it as like a something fun in the company's happening, someone to push a meme. But unfortunately, Adafruit has stopped making this, and they haven't fully committed to why or if they're going to make it again. So we are looking for a new company swag that hopefully can be part of some onboarding fun. Keyboard could be that.
That would be fun.
Yeah.
So actually, I was thinking about recently when I was doing some of my my own streams that it would be really cool, especially if we make this live stream more of a recurring thing, which I think Chris is on board for sure, as our resident content guru. But it would be cool. Yeah, well, now I have a login actually, so so you might just see at all hours of the night. But we also could make this like an on-air kind of thing, and anytime our live stream goes live, our stream goes live, I guess.
I like it.
Everyone gets a like Goliath is live flashing kind of thing. That would be pretty fun.
Yeah, DIY kits. Yep. We are actually working on some kit stuff. But I think an e-paper DIY kit with Goliath would be pretty sick. Good suggestion. I learned all about e-paper. Well, I learned the basics of e-paper from Mike, and it's a weird technology. Like it actually requires domain expertise. It's not like just sending something out to steer, standard out level thing. There's a chip. Each e-paper is different, like custom. Same thing with LCDs, by the way. Like there's a chip that's usually either directly part of the display driver, or one you have to buy that you have to know that only works with this one specific screen. E-paper takes, at least the ones we have, take this weird format. It's like a very specific type of image format. And so like he had to write a script that can take an image of a certain size that then can be converted into something that then can be converted into a file format that we can push down to devices. And so we were talking about maybe one day making that like just a simple service, so you don't have to deal with like the GIMP editor and some weird file concatenation things. And I know it's crazy, but it is fun. Yeah, let me drop the blog. That's a good idea, Dave. David, we should make a kit there.
Yeah, that would be a lot of fun. Well, got about let's see, 80 minutes in here. That feels like a pretty good stream to me.
Yeah.
And we even managed to, well, I mean, we can, have the audience grade us later, but we managed to keep going even without Chris, which is truly a feat, as Chris is a professional, as folks know in this realm. So
Yeah. Well,
at least
we,
on the
we filled
audio
in.
front.
We brought hardware out. Yeah, I think Chris would be pretty proud of us for filling some of that gap, but we definitely need him for the next one. So
Yeah, we also need some doing live demos in some form or fashion. What if we did some live soldering? That would be fun. And we could get graded in real time. I would participate in that for sure. I can get the I have my capture card over here. I could get the overhead camera going, and y'all could tell me how bad it looks.
you should do it after SuperCon. Go there, do the soldering challenge, and then
Yeah.
come back with like super soldering powers and see
Yeah,
before and
yeah.
after. Like we'll take what you have now.
Yeah. I will say my grades were pretty good from Chris and Mike, so we'll see if I can boost them further. But yeah.
I'm just powering. I haven't powered this e-paper on this meme paper in months, so I don't even know
Jeez.
what. There might be some like internal jokes
Yeah,
that might show up here. So I'm like turning the screen around.
We actually just push our balance sheet to that.
Our GitHub keys, streaming.
Yeah.
I'll let that go. Maybe
David says that soldering videos get tons of views. So I've actually watched soldering videos on YouTube for sure. So maybe that's the hack, right? That's what they tell you at Y Combinator. They say it doesn't matter how good your product is, just post
just how good your
soldering.
soldering is.
Yeah, right. Exactly. It looks like Jeff tuned in. Thanks for tuning in, Jeff. Hope everyone has a great weekend. Yeah. Cool. Well, anything else from your side, Jonathan, or should we wrap it up? I'm down to do this again. Although I will be at SuperCon next week. So
well, I saw what the most recent
nice.
meme was. When we change our branding, this is the meme that was going around. The new age.
Oh, hold on. Let me
So
how do I
still.
make it you? There we go. Welcome to the new. Oh, I love it.
Yeah.
Oh, I love the icon is so simple, and I think that's why I love it. I mean, like, I feel like the fact that it just like displays really well on there is evidence of
And we worked with like some pretty high end designers, and they did a lot of iterations to get this design, and
Yeah.
it's kind of interesting that it really fits with a lot of aesthetics that we like. So
yeah, I mean, I'm just looking at even like the border on this video. And especially the business cards that came in yesterday. Ariana is just
well,
incredible.
let me cover. I have one of them.
Okay. Why
I'm
does it keep going to me? There we
I'm
go.
gonna cover my phone number. Maybe they may keep that.
Yeah.
But
there's a little bit of glare, but oh yeah, the back looks so good.
Shout out to Moo, who printed these. We've been using it for our business cards. What you can't tell from the stream is they're like raised. So like the company name. My numbers.
It's all right. We can't see it because of the glare anyway.
But yeah, that's like raised text. Anyway, business cards still a thing.
Yeah. Cool. I will say, Ariana asked me when she was getting them printed, if I needed any. And I was like, oh no, I just like tell people follow me on whatever, or like connect with me on LinkedIn. And then y'all got the copies, and I was like, those are pretty cool. But I truly don't need any, so I'm actually glad that I did say that. But they are extremely cool.
It's interesting because we've been to some pretty big trade shows, conferences, and things like that. And like working in a booth, it didn't matter whose card it was. It was mine. If it was Chris's, we also the one I'm thinking about, Embedded World. We had a generic like sales card. Just having a thing where you can write down who how we met or what booth it was or what what event it was, and then give it them. Just like that piece, that physical piece of paper is actually the biggest value. But anywho, I think we should wrap up. This has been a fun live stream. Thanks for inviting me, and we'll definitely try this again.
Awesome. All right. Well, have a good weekend. Yeah, I'm going to see if Chris is cool with that, and we'll see.
Sounds
All right.
sounds good. Have a good
Have a good
weekend.
weekend. See y'all.
Bye, everyone.